Submarine can use the Doppler effect to detect the speed of the ship. A submarine at rest and just below the surface of the water detects the frequency of a moving ship as 437 Hz, which is 0.985 times the actual frequency of the sound emitted by the ship. The speed of the sound in water is 1470 meters per.
In this numerical problem, there are three questions. First one is state Doppler effect. That usual way the question is asking. State Doppler effect, it is of 2 marks. What is Doppler effect? It is the apparent change in the frequency when there is a relative motion between the source of sound and listener. It is the apparent change in the frequency when there is a relative motion between the source of sound and the listener. In the second question, because the second question is the ship is moving towards the submarine or moving away from the submarine. So in the question, did you notice that the frequency detected by this submarine is 0.985 times. 0.985 times the frequency produced by the ship. That means frequency detected by the submarine is less than the actual frequency of the source. So that means what? The source is moving away from the observer. Here the observer is submarine. Here the source is ship. So here the frequency detected by the submarine is less than. That means it is 0.985 times the actual frequency of the ship. So frequency detected by the submarine is less than the actual frequency produced by the ship. That shows the ship is moving away from the submarine. That is the second question. In the third question, they are asking calculate the speed of the ship. So how will you calculate? There are two methods to solve this problem. Here we are using FL equal to V minus VL divided by V plus Vs into Fs. Because here the frequency detected by the submarine. Submarine means what? It is the listener. So frequency detected by the submarine is less than the frequency of the source. So FL will be less than Fs. So that's why in the numerator minus sign, in the denominator plus sign. In the numerator minus sign, in the denominator plus sign, because FL is less than Fs. From the question it is clear. So here the frequency, in the velocity of the listener. Velocity of the listener means velocity of the submarine. In the question it is clear the submarine is at rest. So VL will be 0. So our equation becomes FL equal to V minus VL divided by V plus Vs into Fs. Here VL is 0. So in the question it is clear frequency detected by the submarine is 0.985 times the frequency produced by the ship. Okay. So frequency produced by the ship is Fs. So frequency detected by the submarine will be 0.985 Fs equal to the speed of sound in water is, it is not 340. 340 is speed of sound in air. The speed of sound in water is 1470. So 1470 minus 0 divided by 1470 plus Vs into Fs. So when you cross multiply 0.985 multiplied by 1470 plus Vs equal to 1470. So again by the mathematical calculation you are getting Vs, that is the speed of the ship, equal to 22.39 meter per second. This is the one method to solve this problem. The another method is, another alternative way is, FL is given, that is the frequency detected by the submarine is 0.985 times the frequency produced by the ship. So FL is given, that is 437 equal to 0.985 Fs. When you take Fs by dividing 437 by 0.985, you will get 443.65 Hz. So Fs you are getting as 443.65 Hz. Frequency detected by the submarine is 0.985 times frequency produced by the ship. Frequency detected by the submarine is given, that is 437, and you are calculating the frequency produced by the ship will be 443.67. Then use the same equation, FL equal to V minus VL divided by V plus Vs. FL is 437 equal to speed of sound in water is 1470 minus 0, 1470 plus Vs, then again 443.65 multiplied, then you are getting the same answer. So these are the two ways to solve this.
The sketch below shows a stationary ambulance. The siren of the ambulance emits sound waves of frequency 700 Hz. The driver of a car approaching the ambulance and passing it at a constant speed. Observe the frequency of emitted sound waves to change by 80 Hz.
In the second numerical problem, the first question is, what is the phenomenon explained in the question and state the phenomenon. The phenomenon explained in the question is directly, it is Doppler effect. What is the definition for Doppler effect? It is the apparent change in the frequency when there is a relative motion between the source of sound and the listener. In the second question, they are asking the speed of the car. In that question, the source of sound is ambulance and it is producing a constant frequency of 700 Hz. So here the source is ambulance and the listener is in the car. So in the question, the car is moving at a constant speed towards the ambulance and then move away from that. So that is the question. The car is moving at a constant speed towards the ambulance and move away from the ambulance. So from that question, you have to calculate the speed of that car. So listen that here there are two cases. In the first case, the car is moving towards the ambulance. So the equation will be frequency heard by the listener in the car equal to V plus VL divided by V minus Vs into Fs. Here the source is ambulance which is at rest. Here the source is ambulance which is at rest. So Vs will be 0. Here the numerator is plus because the source of the listener is moving towards the source. The listener is moving towards the source. So the frequency heard by the listener will be more than the actual frequency. That's why the numerator is plus. Then, in the second case, the car is moving away from the ambulance. So the equation changes. The frequency heard by the listener in the car equal to V minus VL divided by V plus Vs into Fs. Here the numerator is minus. What is the reason? The frequency heard by the listener will be less than the actual frequency because the listener is moving away from the source, which is the ambulance. The listener is moving away from the source. So these are the two cases explained in the question. So the listener is coming towards the source, That is the first case. That is the equation for that is this one. And listener is moving away from the source. This is the equation for that. And from the question, it is clearly mentioned the frequency difference between them is 80 Hz. The frequency heard by the listener when it comes towards the source and move away from the source. There will be a frequency difference that is given by 80 Hz. So we are writing the equation instead of FL1, you can write V plus VL divided by V minus Vs into Fs minus FL2 is V minus VL divided by V plus Vs into Fs equal to 80. So velocity of this sound is 340. In air, the velocity of sound is 340 plus VL divided by 340, Vs is 0. Then frequency of the sound produced from the ambulance is 700 minus 340 minus VL divided by 340 multiplied by 700 equal to 80. Then 2 VL equal to 38.86. VL equal to 19.43 meter per second. This is the solution for the question. So here we are considering two cases. First is the listener is moving towards the source, and the second case is listener is moving away from the source. So from that, in the question it is clearly mentioned the difference in frequency heard by the listener will be is 80 Hz. So putting the equation V plus VL divided by V minus Vs into Fs minus V minus VL divided by V plus Vs into Fs equal to 80. Then substituting the values and by the calculation 2 VL equal to 38.86, then VL equal to 19.43 meter per second. 19.43 meter per second. This is the Doppler effect part 1. In the next session, we will take the Doppler effect part